The elements are the basic building blocks of all materials. This box contains a sample of each element in a small bottle. Theoretically, you could take the elements in these bottles to make any known substance by assembling them into molecules and crystals. A molecule is the smallest particle of a chemical element or compound that has the chemical properties of that element or compound. Molecules are made up of atoms that are held together by chemical bonds. These bonds form as a result of the sharing or exchange of electrons among atoms. Atoms of certain elements bond readily with each other. For example, such elements as oxygen and chlorine readily form bonds with other atoms. The atoms of some elements do not easily bond with other atoms. For example, helium, neon, and argon do not bond with other atoms. Molecules can vary greatly in size and complexity. The element helium is a one-atom molecule. Some molecules consist of two atoms of the same element. For example, O2 is the oxygen molecule most commonly found in the Earth's atmosphere. It has two atoms of oxygen. However, under certain circumstances, oxygen atoms bond into triplets, O3, forming a molecule known as ozone. Other familiar molecules include water, consisting of two hydrogen atoms and one oxygen atom, H2O, sometimes called dihydrogen monoxide, or carbon dioxide, consisting of one carbon atom bonded to two oxygen atoms, CO2, or sulfuric acid, consisting of two hydrogen atoms, one sulfur atom, and four oxygen atoms, H2SO4. Some molecules, notably certain proteins, contain hundreds or even thousands of atoms that join together in chains that can attain considerable lengths. The number of protons in the nucleus of an atom determines where it sits in the periodic table of elements. It is often said that there are 92 naturally occurring elements in the periodic table. Really, there are only 88 naturally occurring chemical elements. The elements 43, 61, 85, and 87 are not stable and very short-lived, so they are not naturally present. But in any case, the important thing for atoms is the number of protons, which determines which element it is. The number of protons in an atom is called its atomic number. For instance, carbon has an atomic number of 6, and therefore has 6 protons and normally has 6 electrons. In addition to the atomic number, there is also the atomic mass, or sometimes called the atomic weight. The mass of an atom is determined by the number of neutrons and protons that are present in the nucleus. The neutron is only slightly more massive than the proton. The atomic mass of this deuterium atom is about 2. The mass of the proton is about 1,836 times greater than a single electron. Thus, the mass contributed by electrons is insignificant when determining atomic mass. The atomic mass is the sum of the protons and neutrons in the nucleus. Most carbon atoms have an atomic mass of 12, which means they have 6 protons and 6 neutrons. Remember, the atomic mass is the number of protons plus the number of neutrons. The atomic mass of most carbon atoms is 12. While that is true of most carbon atoms, the number of protons and electrons remain constant in a neutral atom. The number of neutrons may vary from one atom to another. As a result, the atomic mass for one atom may be different from another of the same element if the number of neutrons varies. Hydrogen is the first element in the periodic table with 1 proton. Although all hydrogen atoms have 1 proton in the nucleus, there are some that have 1 or 2 neutrons in the nucleus as well. Hydrogen with just 1 proton and no neutron is by far the most common isotope of hydrogen. Hydrogen with 1 neutron in the nucleus is called deuterium. Hydrogen with 2 neutrons in the nucleus is called tritium. Tritium is an unstable isotope of hydrogen. It is radioactive. Water, H2O, contains 2 hydrogen atoms in every molecule of water. A small percentage of hydrogen atoms in water have a neutron, or maybe even more rarely 2 neutrons. Molecules of water with extra neutrons is called heavy water. This nitrogen atom has 7 protons, so it would also prefer to have 7 electrons. An atom that has the same number of protons as electrons is said to be a neutral atom. The positive charged protons are equal in number to the negatively charged electrons. Since protons and electrons have equal but opposite charges, the atom is balanced and has no net charge. Unlike protons and neutrons, which are very hard to remove from the atom, electrons can be removed or added to an atom with relatively small amount of energy. An atom with too many or too few electrons is called an ion. When an electron is removed from an atom so that it now has more protons than electrons, it is called a positive ion. When an electron is added to an atom so that it now has more electrons than protons, it is called a negative ion. The two most common ways that atoms become ionized is from light striking the atoms or from electrons striking the atoms, such as from an electric current. The gas in this globe is ionized by the electricity flowing through the gas inside. This fluorescent light also uses ionization to energize the gas. You could say that this man is holding excited atoms. Not all atoms are ionized by energy such as light or electricity. Some may just become excited, which means that the electrons are moved to higher orbits within the atom. When they fall back to a lower orbit, they will emit energy in the form of light. Atoms of different elements take more or less energy to ionize or excite the atoms. Generally, as you move to the right or upwards in the periodic table, the energy required to ionize an atom increases.